Between the shimmering stars that light our night sky lies a vast and silent ocean of darkness, an emptiness so profound it swallows even the faintest glow of distant suns. This is a realm where light fails to penetrate, where time stretches in silence, and where extraordinary worlds drift alone. These are the rogue planets, planets without a home, cast adrift into the cosmic night, wandering forever between the stars. For millennia, humans have looked up, imagining planets as steadfast companions of their stars, locked in graceful, eternal orbits. Yet, hidden from our eyes, the universe whispers a different story of chaos and cosmic violence, where planets are born, wrestled, and cast out. Among the billions of stars in our Milky Way, countless worlds wander alone, silent exiles of the galactic wilderness. Every planet's story begins in the fiery birth of a star, deep within turbulent clouds of gas and dust. These stellar nurseries churn and swirl, where gravity slowly draws matter together, sparking the ignition of new suns. In their wake, disks of leftover material, rock, ice, and gas whirl in a cosmic dance. Within these disks, tiny grains collide and merge, growing over millions of years into boulders, then mountains, then full-fledged planets. But these early planetary systems are anything but serene. Worlds collide and wrestle for space. Orbits shift and tilt. Massive gas giants exert immense gravitational forces, destabilizing smaller siblings. In these chaotic moments, the young planets can be flung outward in violent ejections, breaking free of their parent star's embrace. A planet's destiny can be forever altered in a single, catastrophic encounter. Freed from their sun, these rogue planets plunge into the eternal darkness of interstellar space. Their surfaces freeze under the crushing cold, oceans turn to ice, atmospheres collapse, and worlds become frozen deserts. Yet, beneath the icy crust, heat generated by radioactive decay may sustain hidden oceans, shielding potential life from the abyssal cold. These worlds challenge everything we understand about habitability. Life, as we know it, relies on sunlight. But Earth has shown us that life can thrive in the absence of light, deep in oceanic vents, nourished by chemical energy. Could similar life forms exist beneath the ice of rogue planets, hidden away from the gaze of distant suns? Finding these elusive wanderers is no easy task. Invisible to direct observation, astronomers detect them through gravitational microlensing. When a rogue planet's gravity bends and magnifies the light of a distant star, creating a fleeting, telltale signal. Through this cosmic magnifying glass, we have glimpsed a population of nomadic worlds that may outnumber stars themselves. Some of these planets are gas giants larger than Jupiter, others rocky and cold as frozen deserts. Some may roam forever, isolated and silent, while others might be captured anew by other stars, given a second chance to bask in warmth and light. These rogue planets, drifting in the darkness, tell a story of cosmic resilience and mystery, a story we are only beginning to uncover. To understand rogue planets, we must journey back to the chaotic birthplaces of stars themselves. Deep within immense clouds of gas and dust, called molecular clouds, gravity works relentlessly. Over millions of years, pockets of these clouds collapse, growing denser until nuclear fusion ignites, birthing a new star. Yet stars rarely form alone. Surrounding many young stars is a spinning disk of leftover gas and dust, the protoplanetary disk. Within this disk, an extraordinary process unfolds. Tiny dust particles collide and stick together, gradually building up into larger bodies. This slow but steady accretion marks the first step in planet formation. But this environment is volatile. Emerging planets jostle for position, their growing gravity influencing each other. Massive planets, especially gas giants, dominate the scene. Their immense pull can distort orbits and send smaller planets on wild trajectories. Imagine a young gas giant sweeping through the disk like a cosmic wrecking ball. Its gravitational grip pulls and pushes neighboring planets. Some orbits become unstable. A close encounter between planets can generate enough force to eject a planet entirely from its system, cast into the void like a cosmic cannonball. These ejected worlds are the rogue planets, formed not from a separate process, but as a direct consequence of the turbulence of their birth systems. They carry with them the materials and history of their origins, metals forged in ancient stars, ices accumulated in frigid nebulae, and possibly even prebiotic molecules. The ejection process can be violent and sudden. A single close passage with a gas giant might accelerate a smaller planet to velocities sufficient to escape the gravity of its star forever. Once cast adrift, a planet embarks on a lonely journey through interstellar space, forever severed from its light source. But ejection is not the only path to wandering. Some rogue planets may form alone, directly from the collapse of dense gas clouds too small to ignite nuclear fusion, creating failed stars or planetary mass objects born in isolation. Though rare, these isolated formations blur the lines between planets and brown dwarfs, expanding the diversity of wanderers drifting between the stars. What becomes of a planet once freed from its star's warm embrace? In the depths of space, where temperatures plunge near absolute zero, a rogue planet's surface becomes a frozen wasteland. Oceans solidify into thick ice. Atmospheres condense or freeze, leaving behind thin or absent gaseous envelopes. Under the black void of interstellar space, these worlds seem inhospitable, silent, and barren. Yet beneath the frozen crust, heat simmers. Radioactive decay in the planet's core, a slow but steady process, generates warmth. This internal heat can create subsurface oceans of liquid water, insulated from the frigid vacuum by thick layers of ice. On Earth, hidden beneath kilometers of ice, similar environments exist beneath Antarctica's ice sheets, vast lakes isolated for millions of years. If life emerged on a rogue planet before ejection, it might survive within these hidden oceans, thriving in darkness and pressure. Or life could arise independently, fueled by chemical energy from the planet's core. On Earth, ecosystems flourish around hydrothermal vents, where sunlight never penetrates, but rich chemical reactions sustain diverse life forms. These ecosystems prove that life is resilient and adaptable, capable of surviving in the harshest environments. This realization widens our understanding of the habitable zone, traditionally defined as the region around a star where liquid water can exist on a planet's surface. Rogue planets exist far outside this zone, yet their internal heat might sustain habitable niches, shielded from the cold and radiation of space. Some rogue planets might retain thick atmospheres rich in hydrogen and helium, creating insulating blankets that slow heat loss. Others could have exotic climates, with winds driven by internal heat rather than sunlight. Their surfaces might be covered in ice layers hundreds of kilometers thick, beneath which life may thrive in the dark, alien seas. The possibility of life on these worlds expands the horizon of astrobiology, forcing us to ask, Could life be more common in the universe than previously thought, existing not only on planets orbiting stars, but on lonely wanderers lost in the dark? Detecting rogue planets is one of astronomy's greatest challenges. Unlike planets orbiting stars, they emit no visible light and reflect none from a nearby sun. They are effectively invisible against the backdrop of space. Yet, their gravitational influence offers a subtle clue. Einstein's theory of general relativity predicted that massive objects can bend the path of light. This effect, called gravitational lensing, can magnify and distort the light from distant stars when a foreground object passes precisely in front of them. Astronomers use a specialized form of this effect, gravitational microlensing, to detect rogue planets. When a rogue planet crosses the line of sight between Earth and a distant star, its gravity briefly magnifies the star's light, causing a characteristic brightening lasting hours to days.